Alright, so now that we know about the sum of the interior and exterior angles of a polygon, we can talk about regular polygons. A regular polygon has all congruent sides and all congruent angles. Okay? So given this is a regular blank, mark the diagram. The blank is to test our memory. 1, 2, 3, 4, 5, 6. 6 sides is a hexagon. Alright? So given a regular hexagon, mark the diagram. That means I can mark all of my angles being congruent. And I can mark all of my sides being congruent. Okay? So that's a regular hexagon. Now let's think about how I can find the measure in part A of one interior angle. So one and interior are two keywords that I want you to circle when doing these problems. Because if I'm looking at this picture, the only thing that I know how to find right now is the sum of all of these angles together. Right? All of those angles together I can find using SI. Well, if I want to find one interior angle, that's just going to be I. Okay? And let's imagine that I found the sum of what all of the angles should be by doing 180 times n minus 2, and I'm going to plug in 6 for n. If I knew the sum, the fact that all 6 of these angles are congruent means I can take that sum and divide by 6 to get one angle. So that would be 180 times 4 divided by 6, which is 720 divided by 6, which gets me 120 degrees. That's one angle. That's actually every single one of these. So this one's 120, along with all of the other ones are 120. Okay? Let's look at part B. It now says if the perimeter is 66, find the length of one side. Well, if we remember, the perimeter means all of these sides added together. Okay? So that means there's 6 sides that are the same length added together, and I got 66. So I can take 66 and do the same thing. Divide by 6, and I get 11 centimeters. Okay? So every side was 11 centimeters, and a good way to check is 11 times 6 gets me 66. And I'm good. Okay? Because those 6 sides. All right, let's look at the last one. It says find the measure of one exterior angle. Now, one exterior angle, again, one and exterior is the important word to circle. That's going to be told by E, okay? Now, if all of the interior angles are congruent, that's going to mean that all of the exterior angles are also congruent to each other, okay? Which means, again, we can do the same type of thing. I know that all of these angles together are going to sum to 360 degrees, but there's 6 of them that are congruent, so I can divide by 6, and that means each of them is going to be 60 degrees. Okay? So let's use this to figure out what the formula is. Only in regular polygons, all of my angles and sides have to be congruent in order to use these formulas. The measure of one interior angle is I equals 180 times n minus 2. I'm finding the sum. And then I'm going to divide by n, the number of angles that are in the polygon. And then same idea for the measure of one exterior angle. The sum E equals the sum 360 divided by the fact that there are n angles. And I get 360 divided by n. Okay? Another word that I could say for one is each. All right? Let's look at some examples using these formulas now. All right, so looking at example 1, it says, what is the measure of one interior angle of a regular 15-gon? So let's circle those keywords, one and interior. And it's important to recognize that we're in a regular 15-gon, because that means I can use the formula for one interior, which is I. So I equals 180. Now, what am I going to plug in for n here? N is the number of sides, so I'm going to plug in 15. 15 minus 2 divided by 15. That's 180 times 13 divided by 15, which gets us 2,340 divided by 15, which equals 156 degrees. So each interior angle is 156 degrees. Let's look down at example 2. Example 2 says, what is the measure of one exterior angle of a regular heptagon? Now remember, heptagon means that my n is going to be 7. One exterior, well, that's my E formula, right? E equals 360 divided by n, and n here is 7. So 360 divided by 7 gets me 51.42, but I want to round to 1 decimal place, and that 2 means that the 4 is going to stay the same. It's not going to round up. So 51.4 degrees, and there's my one exterior angle. Looking at example 3, notice I said if each exterior angle of a regular polygon is 30 degrees, how many sides does it have? So the important here is that I have each exterior. Remember, each also means 1. And then I'm talking about a regular polygon. So I know I can use my formula, 360 divided by n. But now the problem is I'm asking you how many sides does it have, and I'm giving you the angle. So in this example, I need to work backwards, like we have in previous examples. So instead, I know the angle, 30 equals 360 divided by n. And how do I solve this equation? Now, I don't want n to be in the denominator, so I'm going to multiply, undo the division, and use multiplication to multiply it to the numerator, and get 30n equals 360. And then this is an easier equation to solve from here, because then I can just divide by 30 on both sides, and I can get that n equals, I think it's 12. All right, so if I get 12 for my n value, that means I had 12 sides. Okay, now there's a couple more examples that your teacher's going to have to go through with you, namely working backwards from the interior angles and some factoring examples that we have. But good luck, and I hope you have a good day.